Hi, 8th grade, and welcome to your very last lesson of Topic 1. We are doing operations with numbers and scientific notation. By the end of the lesson, I want you to be able to confidently say, I can perform operations with numbers and scientific notation. So let's solve and discuss it. The homecoming committee wants to fly an aerial banner over the football game. The banner is 1,280 inches long and 780 inches tall. How many different ways can the area of the banner be expressed? So let's remember that area equals length times width. I want you to pause the video and try and answer this question. There are multiple different answers. Okay, so if we did area equals 1,280 times 780, I could have done it in my calculator to get 998,400. But looking back at our knowledge of scientific notation, we could express the answer like this. We could also put it in scientific notation and write it as 9.984 times 10 to the 1, 2, 3, 4, 5. Remember, since it's a big number, we get a positive 5. We could have also changed this to estimate, which would have given us 1 million, actually. From our estimate, we could have written it as 1 times 10 to the 6th power. We could have also estimated it before we multiplied. So that would have put us at about 1,000 times 800. There, like I said, multiple different ways. And I'm sure we came up with more and got some participation. So which of the solutions is easiest to manipulate? Well, I think it's easiest to manipulate when we estimate first. Whoa. Let's learn how to spell this year. Estimate first. All right. So today we're going to do a lot of work with our scientific notation. Next page. Example number 1, add or subtract numbers in scientific notation. The mass of Earth and the mass of the moon are shown. How much greater is the mass of Earth than that of the moon? So the moon's mass is 7.35 times 10 to the 22nd, and the Earth's mass is 5.97 times 10 to the 24th. So one way we could do it is to write the masses in standard form and then subtract. This is a lot of work because writing out all those zeros and then subtracting, I would be careful with this. Be careful, because if you mess up 1 0 or do 1 extra or 1 less, your whole answer is wrong. It might be easier to keep it in the powers of 10. The problem is when you're adding or subtracting, make sure you write this down. When you're adding or subtracting in scientific notation, you need the same exponent. And you always are going to go with the lower exponent. So is 22 or 24 lower? 22, good. So we have to change this number into having an exponent with 22. So that's what they did here. 5.97 times 10 to the 24th. Well, we know we really want it to be 5.97 times 10 to the 22nd. So that 10 to the 22nd is going to go on the outside. Let me do this so it's a little clearer. 10 to the 22nd, the one we want is going to go on the outside. But to get to the full 24, we break it up between 22 and 2. So remember, that's adding. So then we do 5.97 times 10 to the 2nd power, meaning you move the decimal twice. It's positive, so you move it to the right. So this number, 597 times 10 to the 22nd, although it's not written in correct scientific notation, it's okay for us to use because we need to have the same exponent to add or subtract. This 597 times 10 to the 22nd is the exact same as 5.97 times 10 to the 24th. Okay, now that we have them in the same exponent, we've got 22 and 22, we can add or subtract. In this case, we want to know how much greater, so we have to subtract. What you do is you subtract the numbers, 5.97 minus 10 minus 7.35, and you just keep the 10 to the 22nd coming along. So that gives us 589.65 times 10 to the 22nd. But it's no longer, to make our final answer, we want it in correct standard scientific notation. So I'm going to move the decimal place 2 more, which gets us back to the 24. So the difference is about 5.8965 times 10 to the 24th. Okay, that's a lot, so let's try it. Let this sink in, and we'll try it together. The planet Venus, on average, is 2.5 times 10 to the 7 kilometers from Earth. The planet Mars is on average 2.25 times 10 to the 8th kilometers from Earth. When Venus, Earth, and Mars are aligned, what is the average distance from Venus to Mars? So we need to add them. So we've got this number and this number. Do they have the same exponent? No. Which one is smaller? This 7. So we need to make this 8 a 7. So we know our outside exponent is going to be 10 to the 7th. That's always the lower one. Well, 10 to the 8th is equal to 10 to the 1st times 10 to the 7th. So remember, you add the exponents when multiplying. Keep the base, add the exponents. So we're going to put 10 to the 1st power here, which 2.25 times 10 to the 1st power, 10 is just 1, so you're just going to move the decimal point 1, so we get 22.5. So now we have 2.5 times 10 to the 7th power, times 22.5 times 10 to the 7th. So since we have them both times 10 to the 7th power, we can add the numbers. So 2.5 plus 22.5. So 2.5 plus 22.5 is going to be 25 times 10 to the 7th. But is this in correct scientific notation? No, because 25 is not between 1 and 10. So the decimal point is here. We need to move it 1 more. So we're at 2.5 times 10 to the 8th. Convince me. In example 1 and the try it, why did you move the decimal point to get the final answer? Because it wasn't in correct scientific notation. Remember, scientific notation is one of our vocab words, so you need to make sure you know what it looks like and what it means, what the rules are. Next page. Now we're multiplying numbers in scientific notation. The Confederation Bridge connects New Brunswick to Prince Edward Island. The main part of the bridge rests on piers that form 43 segments. What is the approximate length of the main part of the bridge? Express your answer in scientific notation. So we need to take the length of one segment and multiply it by the number of segments. So we're going to express both numbers in scientific notation as step 1. So we've got 8.2 times 10 to the 2nd. And now 43 is not in scientific notation. The decimal point is here. We move it once. So that's 4.3 times 10 to the first. When you multiply, you do not need same exponent. So that is nice. When you multiply, what you do is you just multiply the numbers. So 8.2 times 10 to the third. And then we multiply the tens with their exponents. So 8.2 times 4.3 gives us 35.26. And now we have to follow the product of powers property. Remember, products of powers, you keep the base and add the exponents. So that's 10 and 2 plus 1. You keep the 10, add 2 plus 1. So that gives us 35.26 times 10 to the third. But again, not written in correct standard scientific notation. We have to move the decimal place one more. So that's going to give us 10 to the fourth. The length of the main part of the bridge is approximately 3.5 times 10 to the fourth. This approximately means that this is an estimate because they rounded 3.526 to just 3.5. Example number 3, dividing numbers in scientific notation. A queen ant lays 1.83 times 10 to the 6 eggs over a period of 30 days. Assuming she lays the same number of eggs each day, about how many eggs does she lay in one day? Express your answer in scientific notation. So we have to divide. We need both numbers to be in scientific notation first. Well, the number of eggs she lays was already there, but 30 is not scientific notation. Our decimal is there. We need to move it once. So it's 3 times 10 to the first power, which is where they have here. Now to divide, we can put it as a fraction. You divide the numbers, so 1.83 divided by 3.0. And then we divide the tens with their exponents. Following division, we've got 1.83 divided by 3.0. It gives us 0.61. And now remember your quotient of powers property that says you keep the base, and subtract the exponents. So that's where they get 6 minus 1 to get 5. Now, 0.61 is not between 1 and 0, so we have to move it 1 to the right, which actually means we're helping make this smaller number a bigger number, so we have to subtract 1 from the exponent. So the queen ant lays about 6.1 times 10 to the 4 eggs per day. Try it on the bottom. There are 1 times 10 to the 14 good bacteria in the human body. There are 2.6 times 10 to the 18 good bacteria among the spectators in a soccer stadium. But how many spectators are in the stadium? Express your answer in scientific notation. You need to multiply the two numbers. Pause the video and press play when you're ready to check your answer. I'm sorry, 8th grade, I misspoke. I didn't read correctly. We have to divide. After that little correction, we find out there are 2.6 times 10 to the 4th good bacteria. There are 2.6 times 10 to the 4th spectators in the stadium. So on the next page, you need to read the properties and show what you do. Remember addition or subtraction, you need the same exponent. In multiplication or division, you need to use the properties we learned earlier. I hope you can say now that you can perform operations with numbers in scientific notation. Have a great day.